Yeah, Simran, speak up. What is it?
Yes, ma'am. Ma'am, when you convert cos into, actually you are first finding the derivative and then converting sine into cos, right?
Yeah. So
So,
you
ma'am, every single time when you convert sine into cos and then find its derivative, minus sign will come in front.
so that minus sign is taking care of conversion also, no?
Ma'am,
Okay,
for the
let's begin
even
this.
derivative.
You look into your notebook and answer these questions. Okay, y is equal to just cos ax plus b, right? Y is, you look
Yes,
into your
ma'am.
notebook and answer these questions. Y equal to cos ax plus b. So what
Yes,
is
ma'am. Yes,
y1?
ma'am.
Y1 is
Minus sine
minus
of
a sine ax plus b.
AX plus B. Right.
Minus a sine ax plus b. That means
Yes,
a
ma'am.
minus sign is coming. So that minus sign you're converting back into cos. So that means your first derivative is cos of ax plus b plus pi by 2. A cos
Yes.
ax plus b plus pi by 2. Okay, so your first derivative does not have a negative sign because you converted your minus sign to cos, right?
Ma'am, how is that possible? Like negative sign is not linked with this identity of sine and cos with theta and pi by 2. I mean sine theta plus pi by 2 is cos theta and cos theta plus pi by 2 is sine theta. There is no minus sign involved in it.
No, there is a minus sign. What about the
Okay,
others?
okay, 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 I got it. That's pi by 2 message. Right. Thank you.
What did you get? You tell me.
That I am assuming that that identity is there in my mind sine pi by 2 minus theta. It's in the second quadrant I just realized.
No, no, this will have a negative sign because that negative sign is coming in the conversion and one sign coming in the derivation. Both are getting cancelled out. And main
Yes,
stage
ma'am,
we
I
are
got
getting
it.
only positive. Yeah. What
I
about the
got it.
others?
Okay.
What about the others? Any repeat for the cos function? Any repeat for the cos function? Right, okay. So you're not mentioning repeat, I'm proceeding. So these are the two formula. Everything is right in the slide. Only a second equation is missing for y2 that you make sure it's there in your notebook. Okay, so make sure this line comes there because only when you look at this line, you're able to predict your third derivative. And from third derivative, you're predicting your nth derivative. Okay, so look at your second line. One line you need to add your y2. Okay, what have I written there? A square into sine ax plus b plus 2 into pi by 2. And then these two identities which you have, you know these better than myself. Sine of theta plus pi by 2 is cos theta. Cos of theta plus pi by 2 is a minus sine theta. You write them in the rough column there. So those will help you derive it. Okay. Anybody doing it, mention or doing it. Otherwise, we're moving on. Yeah, yeah. Hurry up. Rishikesh, they use something called all silver teacups or something when they're doing the quadrants. Yeah, from those quadrants, they get those formula. Go back to your 12th textbook and look into those. Yeah. Not yet. I have the Yeah, the writing pad, but I've still not used this. I'm supposed to use it on a 1-2. Yeah. I've not found the time to practice it. Yeah, it's slightly different from the normal pen, so it's taking time. I'm not able to get the time to practice. Yeah. Well, I'll do that from probably at least by the weekend. By Saturday, I will try to start using that. So then I can leave a slide in between for some rough work. Yeah. I will leave one slide in between for rough work and then I will start using that writing pad. Yeah. Right. Okay. I'm moving on. Nobody's mentioned anything, no repeat or no noting down, doing it. Okay. So I move on. So now if this is the derivative of sine and cos functions, how do we do these questions? Look at these questions. First is a sine square x and second is a cos power 4x. Okay, sine square x and a cos power 4x. So that's our first. So to get our sine square x, can I write it in term? Because we only know how to handle sine or just a cos function because the nth derivative we have found only for sine function or cos function. So here is a sine square, higher powers are there, you bring it to the lower powers. So whichever identity comes to your mind, you use that and see how you can, because the derivations that you have done are only for sine function and cos function and not their powers. So that is why sine square x, can we rewrite it as that 1 minus cos 2x by 2? Yes, you have such formula. Sine square x is 1 minus cos 2x by 2. Cos square x is a 1 plus cos 2x by 2. Yeah, okay, so those formula you can write and all we did is we just rewrote. Okay, now can I see that this y is just involving a cos function and not its powers? So can I straight away find its nth derivative? I don't need to find y1, y2, and so on. We have a formula for cos function. This y straight away we apply the nth derivative. If I apply the nth derivative of 1, what would I get? Would I get a 0? Half into 1 minus half into cos 2x. So 1 nth derivative is 0. So I only have to find the nth derivative of minus cos 2x by 2. So this is what you need to evaluate. You need to find the nth derivative of minus half cos 2x. Yeah. Now minus half cos 2x. Yeah. Minus half cos 2x. You can see that. Yeah. So minus half cos 2x. This is a cos ax plus b form. Cos ax plus b form. So 2 is 2 coming to the power n here. 2 power n. And cos 2x plus n pi by 2. Check whether this formula is right. Minus half is there. That's a constant which will remain as it is. Nth derivative of cos 2x gives me a 2 power n. And then it is cos of 2x plus n into pi by 2. Now, this 2 and this 2, would the power become 2 power n minus 1? Would it become a 2 power n minus 1? And then we still have a cos function. Yeah, 2x plus n pi by 2. So it's a straightforward question. All you had to do is you had to remember one identity which reduces a sine square function to just a cos or just a sine. Any repeat for this question? Third step, okay. We want to find the nth derivative of sine square. So sine square formula is to reduce it in terms of sine or cos, we have a 1 minus cos 2x by 2. So we just rewriting sine square as a 1 minus cos 2x by 2. Now we want to find the nth derivative of this function. 1 minus cos 2x by 2. So to find the nth derivative of this function, what is the nth derivative of 1? What is the derivative of 1? Derivative of 1 is 0. So nth derivative is going to be 0. So you're only finding the nth derivative of your cos 2x function, which has a negative sign and a half ahead. So basically you're finding only the nth derivative of cos 2x with a minus half ahead. Now nth derivative of cos 2x, turn pages, look at the derivation which you've done in the previous slide. nth derivative of cos ax plus b is a power n. In place of a, here we have a 2. So you're writing 2 power n and cos of 2x plus n pi by 2. So that's why you're writing yn equal to minus half 2 power n cos 2x plus n pi by 2. And then you can see that 2 in the denominator and a 2 power n in the numerator. You can cancel out a 1, 2, and you still have a 2 power n minus 1. Yeah, and within brackets, it's a cos 2x plus n pi by 2. Anybody doing it? Mention doing it, please. Which step exactly, Mark? This one? How to find the nth derivative of this one or the previous step? How to find the nth derivative of this one or the previous step, Mark? Okay, nth derivative of this one. Right. Okay, we are finding the yn, which is the dn. dn is your nth derivative. D power n is the nth derivative of cos 2x. Okay, he's using that notation, nth derivative as a capital D power n. So that minus half constant he kept as it is. And what is the nth derivative of cos 2x by the previous slide? Cos 2x nth derivative is 2 power n into cos of 2x plus n pi by 2. 2 power n, because in place of a you have a 2 here, ax plus b. In place of b you have a 0, and in place of a you have a 2. So 2 power n, and then cos of 2x plus n pi by 2, because you're writing the nth derivative now. Check again. That 1 minus cos 2x, 1 becomes a 0 because nth derivative of 1 is 0. Talking about the conversion of second to third ones. Okay, Mark, I'll just unmute you, just try. Yes, Mark, go ahead. What is it?
Ma'am, am I audible?
Yeah, we can hear you.
Ma'am, I am talking about the first step, 1 by 2 dn, 1 minus cos 2x, where that 1 has gone, ma'am. The
Okay.
1 minus cos.
Okay. Yeah. So this is my y, Mark. I want to find the nth derivative. So that is nothing but half of the nth derivative of 1 minus cos 2x, because half is a constant that we wrote ahead. We want to find the nth derivative of 1 minus cos 2x. So he's writing dn of 1 minus cos 2x. But derivative, when you're finding, you want to find the derivative of 1, you want to find the derivative of minus cos 2x. So derivative of 1 we know is 0, because it's a constant term. So first derivative itself is 0, nth derivative will definitely be 0. So that is why that 0 is not mentioned there. We are only writing the nth derivative of minus cos 2x. So minus also is ahead. And now find the nth derivative of cos 2x. Nth derivative of cos 2x, we have the formula from the previous slide, which is a 2 power n cos of 2x plus n pi by 2. Right, anybody doing it? Mention doing it if you're still on the slide. Okay, so I don't see her doing it, so I'm assuming you guys have finished. Yeah. What about a cos 4x? See what he's doing. Cos 4x is straight away taking, yeah. He's rewriting his function, because you can apply the nth derivative only on a sine function or a cos function, not on their powers. So if you rewrite your cos power 4x, can you write it as a cos square x whole square? Cos square x whole square. But what is a cos square x? Is it a 1 plus cos 2x by 2? It is a 1 plus cos 2x by 2. So 1 plus cos 2x by 2 whole square. So you get a 1 by 4 ahead and you still have a 1 plus cos 2x whole square. Now, if you open brackets cos square, do an a plus b whole square, you get a 1 plus 2 cos 2x and a cos square 2x. Quickly confirm if it is right till this step. Yeah, okay. Now, 1 is no problem for us. A cos 2x is no problem. Again, cos square is the problem because higher powers of x, cos and sine, we don't know how to handle. Again, he's converting cos square in terms of cos. So you will get a 1 plus cos 4x by 2. So cos square 2x is there. If cos square x is there, 1 plus cos 2x. If cos square 2x is there, 1 plus cos 4x will come with the 2 in the denominator. And then you can see a constant 1, a 2 cos 2x, again a constant term, and again a cos function. So constants, you bring them ahead, and then you just see that you have a cos 2x term coming, a cos 4x term coming, and you know clearly how to find the nth derivative of cos 2x term and cos 4x term. This 1 by 4 plus 1 by 8, whatever it is, its derivative is 0. So those terms will vanish. You only have to take care of your cos function, cos 2x and cos 4x. Any repeat? Any repeat? You're just using your trigonometric identities that you will have to brush up. Yeah. You have to go back to your 12th class textbook and note your trigonometric identities somewhere. Yeah. Any repeat for whatever I finished till now? Because after this, you're just applying the formula for your cos function. A is 2 for the first cos function. A is 4 for the second cos function. So that's why a 2 power n is coming, a 4 power n is coming, and then you're just simplifying it further. 4 power n, y is the denominator in the second last step. Okay. Second last step, a half is there ahead. Yeah. A half is there ahead, and this is a 1 by 8. Yes, Simran, this is a 1 by 8. Yeah, and then a 4 power n can be written as a 2 square power n, 2 power 2n. Okay, and then a 2 power 3 in the denominator, a 2 power 2n in the numerator. So you are getting a 2 power 2n minus 3. Yeah, so the first, because you know the formula for cos ax plus b, cos ax plus b. So what is a in this case? Neon. What is a in this case? Cos ax plus b. If you know the formula, what is a here? Compare it with the cos ax plus b. What is a? 2. Yeah, what about this one? Cos ax plus b, if I compare with the formula, is 4. So that is why a 2 power n, a 4 power n is coming because you are applying that formula again. Yeah, any repeat? Please mention a repeat. Vibhu, are you there? Yes, I asked you something. Is it a yes from your side? Vibhu, go back to the chat box right from the beginning, scroll down and read the chat box. Right from the beginning, go through the chats and give me a response, Vibhu. Yes, anybody doing it, mention doing it. Otherwise, I am moving ahead. Yeah, hurry up. No, both of you will be there. John also will be there, Vibhu. Two of you will be there. Yeah, thank you. Okay, so yeah, I'll scroll it down. I have to remove the annotation. Please remember to put a 1/8 here. I will remove the annotation. It's a 1/8. Yeah, two of you, John and Vibhu, both of you will be the representatives for the Mathematics Association. Yeah, John and Vibhu will be the representatives for the Mathematics Association for this academic year. Okay, so the inauguration will happen sometime next week, and after that, it will be some activities which will happen for the mathematics department. So, congratulations to both of you, John and Vibhu. Right. This academic year, which is already, yeah, half the academic year has gone by. So, we just, because it was online, we were wondering whether we should start or not, but then we decided to go ahead. Yeah, so this Mathematics Association basically will be conducting events, conducting, yeah, fairs for the department. They will conduct events for the department. They will conduct guest lectures for the department. So each class will have two representatives. So for this academic year, John and Vibhu will be in the committee. Yeah. Yeah, please send a WhatsApp message, the two of you with your yeah, details, full name, and then your register number completely. Please send a WhatsApp message to me, Vibhu and John. Right, okay, I'm moving ahead. I'm assuming you finished. Okay. How do you handle a question like this? Because we know only how to handle just a sign or just a cos. This question has both sign and cos coming. So you can see that you need to rewrite your function. You need to rewrite in such a way that you exclusively get a sine function or a cos function. You can't have the products coming, because when you're finding the nth derivative, we only know how to handle just a sine function or a cos function. So look at the first expression, cos cube x. Can it be written as a cos square x into cos x? Is this step okay? The cos cube x will be written as a cos square x into cos x. Right? Yeah. Next, sine square x is there, cos square x is there. Can you combine it and write it as a, yeah, sine 2x, sine 2x by 2? Sine square x and a cos square x is there. Can you combine it and write it as a sine 2x by 2 whole square? Because what is a 2 sine x cos x? It is a sine 2x. Yeah, 2 sine x cos x is a sine 2x. So that is why sine square x cos square x, you will have a, yeah, sine square x cos square x, you will have a sine 2x by 2 whole square. Okay, so that's a sine square 2x by 4. Any repeat till here? We're rewriting and trying to put all the identities that we know. All I want you to get is exclusively in terms of sine or cos. Okay. Next, again, sine square 2x is converting into cos function. So he's writing it as a 1 minus cos 4x by 2. So now you have got in terms of just a cos. Okay, open brackets, you get the first term as a cos x, second term as a cos a cos b. And again, what is the formula for cos a cos b? Cos a plus b by, yeah, cos a plus b plus cos a minus b. So you will get this one, because cos a plus b plus cos a minus b is of 2 cos a cos b. Okay. I feel very sad for you that you have to remember this many formula, because yeah, if I had to remember, I would find it really difficult to remember so many. Okay, so I can only feel sad for you, but I can't exempt you from remembering those. Yeah. Okay, so somewhere keep writing them again and again in the rough column so that they remain in your head, because you will need a lot of trigonometric identities to do these questions. Yeah. Any repeat till this step? Hurry up, hurry up. Any repeat till this step? 2 cos a cos b is cos of a plus b plus cos of a minus b. So 4x and x is there. So cos 5x and cos 3x. Okay, I don't see any repeats there. Now have we rewritten? Yeah, I will explain. Yeah, have we rewritten the first function which is given in the question now in terms of exclusively cos? Each step is just involving a cos ax plus b, cos ax plus b with a equal to 1, cos ax plus b with an a equal to 5, cos ax plus b with an a equal to 3. Yeah. Right. Okay. Now, once you get exclusively in terms of cos, you can apply the nth derivative formula, and this would be your final answer. So first one is, yeah, 1 power n, because a is 1 for the first one, 5 power n for the second one, and then a 3 power n for the third term. Yeah. Which step do I have to explain? Fifth step. Okay. This one, Syed, is it this? Yeah. Okay. So previous step has a cos A. Cos X is no problem. We know how to find its nth derivative. The next is a cos A cos B formula. Okay. Cos A cos B is there. I need to separate them. I need to get only in terms of cos or sine. I can't have product of two functions coming. So cos A cos B formula is 2 cos A cos B is equal to cos A plus B plus cos A minus B. So that is why cos A plus B is 4x plus x, which is a 5x, 4x minus x, which is a 3x. And a half will come ahead because it's a 2 cos A cos B formula. So write it there in the rough column, and then you can see that you have 3 separate cos functions coming. And for all the 3, you know how to apply the nth derivative. Any repeat, please mention a repeat. Otherwise, we'll move on. The formula, okay. Okay. Syed, if only it were a 2 sin A sin B, what would have come? Syed, if it were a 2 sin A sin B, what would you write? How will the formula change? 2 sin A sin B. Last step, there should be a minus sign for the nth derivative. Last step, there should be a minus sign for the nth derivative. Where is it? Atharva, is it this? This will be a negative sign, right? Yeah, okay, right. This will be a negative sign because you can see the previous step, there is a negative sign. Yeah. Any other mistakes? Constants are okay? First term also. This, there won't be a 2 here, right? There will not be a 2. Check again. Simran, check again. Yeah, x plus n pi by 2. Okay, 2 mistakes. The 2 cos x, 2 came ahead. So just the cos x, you are applying the nth derivative. So it's a cos of x plus n pi by 2. Yeah. Any other mistakes? Anybody? Yeah, Bhavya's mentioned doing it. Hurry up, Bhavya. Yeah, please go ahead. Any method. This is not the only way to do it. You can you play around with your trigonometric identities that you know, just get in terms of cos or sine and apply the nth derivative. Yeah, Bhavya, have you finished? Can I move ahead? We just have few more minutes. Arpan is creating some identities there for you. Please check and use those if you can avoid this many steps. Bhavya, have you finished? Yeah. Anybody doing it? 30 seconds, I wait. Mention it, doing it. Right, okay, so I don't see her doing it. I'm moving ahead. Yeah, so these are the questions that are given to you. Okay, so quickly tell me how you will do those and then you can go ahead. You can leave the class. If you finished, these are the questions I want you to try. Today itself, you will finish off these questions. Do not keep it for another day. Okay, your identities are fresh in your head. Yeah, so use your identities and finish it off. First two are straightforward questions, no need to rewrite. Third one, do you have to rewrite? Third one, do you have to rewrite? Yes. Okay. So you're using the formula. Yeah, sin A cos B formula. Sin A cos B formula you have to use. Yeah. Next one, sine square, you can always convert into cos function. Yeah, because you know it's a 1 minus cos 3x by 2. Cos cube is there that you can write it again as a cos square into cos, and then you bring in your identities and then solve that. What about the last one? Last one, sin A sin B formula is there that you can bring in your cos functions and then open brackets, apply the cos A cos B formula. You might get a lot of terms. Yeah. Okay, all these can be addressed. Okay, so today itself, you make sure you complete it in the next 10 minutes, you finish it off. Any other doubts, you can stay back. Otherwise, just take a Yeah, what is it you taught me last class? Screenshot or screen snap. Yeah, take a screen snap and yeah, take it and leave it and finish it off. Okay, this is for your own good.